Today's lesson is called Graphing Inequalities Day 2. In example 1, we're going to look at graphing in one variable versus two variables. Let's start first with looking at examples of graphing two variables, y is greater than 3 versus x is less than or equal to -2. So we'll start with the left side, y is greater than 3, okay? The steps to graph something like this is first, you're going to graph on the line y equals 3. We discussed horizontal and vertical lines in previous lessons. So if you think back and remember, if y is 3 and I make an xy table, my entire side of y's gets filled in with 3's no matter what the x's are. It means that it crosses the y-axis at 3. So I would go up here and plot my point, and I know I'm going to make a horizontal line cutting across that y-axis. Now I need to think about how I'm going to connect these. Is it going to be a solid line because the 3 is included, or is it going to be a dotted line because the 3 is not included? Since we have y is greater than 3, that means the 3 is not included in the answer. So we are going to make a decision about the line and decide that it's going to be a dotted line to show that 3 does not count. Then we need to consider where to shade. So we'll do our dotted line first to represent our line y is equal to 3, but showing that since y is greater than 3, 3 does not count. And then if I want the values that are greater than 3, then I know I need to shade above. So I'm going to shade above to show where my solutions are. And then, of course, I'm going to make sure that I label. So this is y is greater than 3. Now, on the other side, let's look at x is less than or equal to -2. So similarly, we need to graph the line on x equals -2. So if I were to give you an xy table, if x is -2, it's always -2. So I would kind of autofill the side of x's with -2's. And it does not matter what my y's are. Hopefully that jogs your memory and reminds you that if it's an x equals line, it's going to cross the x-axis at that value. So x equals -2 on that x-axis. And then it's going to be a vertical line. Now let's think about how we'll connect it. It says x is less than or equal to -2, which means that -2 is included. So we're going to show that with a solid line. And then if I want the numbers that are less than -2, I'm going to shade to the left. So shade to the left. Now let's look at some similarities and differences between these. So first, similarities. If I take a look at the pictures, we definitely have some shading going on for both of them. It may not be in the same place, but we do have part of the coordinate plane that is shaded in. So I'm going to say shaded region that is a portion of the coordinate plane. Represents the solution. That's the case in both situations. Some of the differences we have is first of all, dotted versus solid. So one of ours was greater than, the value wasn't included, that's why we had a dotted line. The other one was less than or equal to, the value was included, so we had a solid line. And then, of course, the lines themselves. The y equals line was horizontal, the x equals line was vertical. So we have vertical, remember, which is x equals a, versus horizontal, which is y equals b. So there's what it looks like even though y is greater than 3 looks like one variable and x is less than or equal to -2 looks like one variable, we're graphing them in two variables, which is why it looks the way it does on the coordinate plane. Now, let's look at example 2, graphing one variable versus graphing two variables. So basically looking at last chapter versus this chapter. It says graph the solution set to x is less than -5, reading it as an inequality in one variable. So we're going to do that on the left, and describe the solution set in words. Then graph the solution set to x is less than -5 again, this time reading it as an inequality in two variables, which we're going to do on the right, and describe the solution in words. So let's see how the graph is affected. First, let's start with one variable, which is a review from last chapter. If I have x is less than -5, in words, we have x is less than -5. Now, I can just do that right away from reading it, but I also could do that after creating the graph. If I was going to go back, remember, and write that in set notation, it would look like x such that x is less than -5. Let's think about the graph. So if it's in one variable, we're only using one number line, which is the x-axis. I have to think about my circle. I know the critical number is -5, so that's where my circle is going to go. And then I have to say to myself, okay, is -5 included? So fill in the circle. Or is -5 not included, which means leave it open. Since x is less than -5, -5 does not count, so I'm going to leave it as an open circle. Then I want to shade all the numbers that are less than -5. So I'm going to shade to the left. Okay. If we wanted to review interval notation with this, we have two numbers. -5 is actually our higher number, so that goes on the right. It's going towards -infinity. -infinity or positive infinity is never included. And then -5 on the right is not included either, so those are open brackets. Let's compare that with graphing this in two variables. So thinking back, you're going to graph x equals -5, which means, again, if I had a table, the x side is always going to be -5, no matter what the y values are. Or remember that if x equals -5, you're going to make an x-intercept of -5 and draw a vertical line through it. Now, x is less than -5. So if I'm picking between dotted and solid, I want to pick a dotted line because the -5 is not included. Then I'm going to look and see, okay, I want the numbers that are less than -5. So that means I need to shade to the left of the line. Then I label with x is less than -5. Now, if I were going to describe that in words, I would say it's all ordered pairs, which is clearly different than in one variable, right? Because now you have an x and a y, such that x is less than -5. So if I'm going to compare these two, I can see how some things translate. For example, over here on the left, an open circle translates to two variables as being a dotted line. But I also noticed that we have shading in both, and for both of them, the shading went to the left. So there's a look at a one variable situation right next to a two variable situation and seeing the differences between the two. Now let's move on to example 3. Example 3 says graphing using the intercepts of an inequality. So we discussed how to graph a linear equation in two variables when it's in standard form by finding the intercepts. We can also do that same thing when trying to graph an inequality. So rather than putting this inequality in to y equals mx plus b type form, we're going to use intercepts to graph it. So first let's start with the x-intercept, which remember means we want to find out x when y is 0. So I would write my equation, not inequality, in order to determine the exact points. I'm going to replace y with 0. Then I'm going to do the math here. So that's really 2x equals 3, which means I would have to divide both sides by 2, and I get that x is equal to 1.5. So that means one of the coordinates I'm going to plot is 1.5, 0. Then I'm going to find the y-intercept by plugging in x equals 0. So I'm going to write my equation. And then I'm going to plug in x is 0. So 2 times 0 is 0, which leaves me with negative y equals 3. But I don't want negative y, so I have to divide both sides by a negative 1. And I get y equals negative 3. So my y-intercept is going to be 0, negative 3. So now I can go over to the graph and plot those two coordinates, 1.5, 0. And 0, negative 3. Then I'm going to go back up to the inequality and pay attention to the symbol here. It's less than, which means the 3 is not included. So that means we need to create a dotted line. Now, when it comes to shading and the lines are tilted this way, as we've talked about before, it's best to check a value. And the easiest value to check is 0, 0. So 0, 0 is the origin. If I check that point in the inequality and it does work, then I know to shade towards 0, 0. If I check that value and it does not work, then I know to shade the opposite direction. So up here, I'm going to take my inequality, 2x minus y is less than 3. And I'm going to check the point 0, 0, which means my x is 0 and my y is 0. 2 times 0 is 0. 0 minus 0 is 0. Is 0 really less than 3? Yes, it is. So that means I need to shade towards 0, 0 to make sure that 0, 0 is part of my solution to my inequality. And then lastly, I'm going to label it with the original inequality. So you can use your strategy of finding intercepts also when graphing and solving, finding solutions to linear inequalities, okay, in two variables. So in the last section of our notes, I would like you to do a few practice questions. It says, graph the following on the same coordinate plane. Graph the inequalities on the same coordinate plane and show all your work. So you see number 1 and number 2 there. And then number 3 wants you to name a solution that satisfies both inequalities in problems 1 and 2 above and explain your reasoning. So at this time, I'd like you to pause the video and try these 3 practice questions by yourself. And then when you're ready to check your answers, you can resume. Okay, so at this time, you've had a chance to try the practice questions, and now you're going to check your answers. So in number 1, I did change it to y is greater than or equal to 5 to help us with graphing. Since it's or equal to, I know it's going to be a solid line. In order to get that line, remember you can use a table as a resource. So if I'm graphing y equals 5, all my y values are 5, which remember means it's going to be a horizontal line with a y-intercept of 5. I did put in there that technically y equals lines have a slope of 0 and a y-intercept of 5. And since it is greater than or equal to 5, when you switch it around there, you want to make sure you're shading above. Don't forget to label your inequality in the region. In number 2, this is closest to looking like y equals mx plus b form. So I decided to go that route. I got y by itself by dividing everything by 2, which left me with y is less than or equal to 1/2 x plus 4. That means my slope is 1/2. I'm going up 1 to the right 2. And my y-intercept b is 4, which means the first coordinate I'm going to plot is 0, 4. It is going to be a solid line because, again, it was or equal to. For this one, I checked a point, 0, 0, to see where I should shade. When I check 0, 0, it is a true statement. 0 is less than or equal to 8. So I make sure I shade towards 0, 0 again and label my inequality. So number 3, name a solution that satisfies both inequalities in problems number 1 and 2 above. Explain your reasoning. So the point that I chose was 8, 7. That's just an example of one point. What you want to make sure you do is pick a point that's in the region that is shaded for both inequalities. So I picked 8, 7 because this point lies in the shaded region for both inequalities, or sometimes referred to the double shaded region. And I drew an arrow up there. I plotted 8, 7 so you could see what I mean. That is falling into both areas, both pink and teal there, which means it's a solution to both. So an ordered pair, remember, is a solution to a two-variable inequality if, when each number is substituted into its corresponding variable, it makes the inequality a true number sentence. Each ordered pair of numbers in the solution set of the inequality corresponds to a point on the coordinate plane. The set of all these points is called the graph of the inequality. And the graph of a linear inequality in the coordinate plane is called a half plane. That just means, remember, that part of the coordinate plane is going to be shaded in as your solution. And this concludes your lesson on graphing inequalities, day 2.